All right, in the last video, I was graphing this quadratic and I was just about to type in a 0 over here. So again, what I'm doing is I'm taking this original function, 2x squared minus 8x plus 9, and I'm plugging in all of these x values. I started with 2 because that's what my formula for vertex and axis of symmetry gave me. So I did find that this one was 9, so I'm going to write a 9 in here, and I was just about to type in 0. Okay, so I'm fixing this to zeros. And that was 9. Now, we should have known that the 0 was 9 at the very beginning of the problem because when x is 0, we have a y-intercept. And our y-intercept always matches with our c value. So I can actually fill that in as 0, 9 right there. My vertex is 2, 1. So I'm going to graph all of this. 0, 9. Oopsies. That's a 3. Let me show you back in the calculator. See, 1 gave me 3. I don't know why I wrote that. Okay, 1, 1, 3, 2, 1, 3, 3, 4, 9. Okay, connect this into a nice smooth parabola, not pointy or anything. All right, so I can see that my axis of symmetry goes straight down through the vertex, and that is at the x value of 2. That should always match your vertex. I have a minimum value because that vertex is the lowest point on my graph. My domain is always all real numbers. You can write that like this too. Because these arrows are getting wider and wider in both directions every single time. It's always going out, out, out forever in both directions. My range is from my lowest to my highest. So the lowest that I go on the y values is a 1, and the highest that I go on my y values is infinity. You can also write that y is greater than or equal to 1 is another way to write that. You could also write it in words. All real numbers greater than or equal to 1. You don't have to write all 3 ways. It's just some different ways you might see it. Okay. Whoops. Number 10 is very similar, except we have a negative in front of x squared. So that means my A is negative 1, my B is positive 2, and my C is positive 4. So my formula to find the x value of the vertex and the axis of symmetry is x equals opposite of B divided by 2 times A. The opposite of B is negative 2 because B is 2, so opposite of B. And then 2 times A is negative 1. This is negative 2 over negative 2, which simplifies to 1. That's the x value of my vertex. So I know that bigger than 1 is 2 and 3, and smaller than 1 is 0 and negative 1. So I'm going to take my calculator and I'm going to plug in a 1. Now, we're plugging in a 1, a positive 1. But my formula or my function has a negative right here. So then I have 1 squared plus 2 times 1 plus 4. That's what I'm typing in, exactly how you see it. Negative. So it's this button right here under the 3. 1 squared plus 2 times 1 plus 4 gives me 5. Okay, now I'm going to just go ahead and redo that calculation for 2 and 3. So up, up, enter. 2, 4, up, enter. 3, 4, and 1. Decreasing. Okay. When I plug in a 0, I should get 4 because that's my y-intercept again. But I'm just going to double check with my calculator. Up, enter, 0, 0. Okay, did it. Now, when I plug in a -1, that negative right there is not sufficient for plugging in a -1. That was actually part of the original function. So I need a -1 in, no, not like that. I need a -1 in parentheses like that when I'm doing this calculation, because I already know what it's supposed to be. It's supposed to match with 1. Okay, so 4, 1, 4, 1, same thing. We should see that. Should see that symmetry here and here. Okay, -1, +1. 0, 4, 1, 5, 2, 4, 3, 1. So I don't know exactly where the x-intercepts are. I mean, I could keep going in my calculator to find them. I can kind of estimate where they would be. Speaking of that, let me go back. Oh, this is going to take me forever, but I wanted to talk about this last function real quick. Forgot to talk about x-intercepts. I'm going to regret this. Oops. Okay. So when I look at this graph, it was that vertex was at what? 2, 1? There are no x-intercepts here. There aren't any. It doesn't cross the x-axis. Does that happen all the time? Not all the time. It happens every once in a while, though, that we don't have any x-intercepts. Okay, that's not going to work for me. Okay, I'm just going to have to go down here and just rewrite this stuff. Okay, so what was my vertex again? Let's look at my calculator. It was 1, 5, and then I had 4s and 1s. Okay, so I had 1, 5, and then this was 2, 3, 4, 1, 0, -1, 4, 1. Okay, so I was here, 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 here. Oh my goodness. -1, +1. Okay. There, there. Okay. All right, so my vertex, 1, 5. My axis of symmetry goes straight down through the vertex, through that x value of 1. My y-intercept I knew was 0, 4. I can find it right there. This is a maximum because it's the highest that my graph goes, is the vertex. The vertex is that highest point. My domain, all reals. I can write -infinity to +infinity, whatever. And my range goes down forever. And the highest that it goes is 5. Or I could write y is less than or equal to 5 is another thing I could write. Or I could write all reals less than or equal to 5. All right. Next section. Write the quadratic in standard form, which is ax² plus bx plus c, given the following information. So if my vertex is at 3, 1, and I have a point at 4, 3, let's graph that. 3, 1. 4, 3. I know that my axis of symmetry goes straight down through the vertex. So if one of my points is here at 4, 3, then my other point has to be 1 over from the axis of symmetry as well at the same height. So that's at 2, 3. This is my other point. Because of the axis of symmetry means that it's the same thing on both sides. Oh, and I'm reaching the end of my video again. Sorry, I'll continue in the next one.